Hello and welcome to a new session in the series Architecture Design Patterns. In today's session, we will discuss the API Gateway pattern. Moreover, we will dive into topics such as security with Azure Firewall and authentication authorization with Microsoft Intro ID. Remember, we can always replace the Azure components with open source components. For example, Azure Firewall could be Cisco Firewall, and Microsoft Intro ID could be replaced with the Keycloak open source tool for authentication authorization. Let's get started into today's session. We continue the case study we have started in a previous session. For a recap, let's review. We started with a monolith application for an airline flight systems, and the work package was to introduce a new mobile application for passengers to book the flights themselves. We introduced the refactoring or the migration to the cloud using the triangular pattern, as we can see on the screen. This has been one of the topics we have discussed in a previous session. Moreover, we have discussed the flavors of the command query responsibility segregation pattern, as you have seen here, how to separate the writing from the reading of the data to allow more scalability and flexibility, and also to be able to adapt to future changes and requirements. We have seen the asynchronous pattern using a Kafka topic or any message bus. If we are sticking to the Azure cloud, whether we say Azure Service Bus or Azure Event Hub, these are all possibilities that you can plug and play in your architecture design. So let's get started with the topic of today's session, API Gateway. So the API Gateway here, we have settled it in the middle of our communication between the mobile application and the services. The API gateway is an L7 layer of the OCI model. That means it's on the application layer, works with HTTP, HTTPS. This API gateway could be Gravity API gateway, could be any other open source gateway. It could be also the Microsoft Azure API gateway. Moreover, on the L4 layer, we set up an Azure firewall so that we can filter all the communication, avoid DDoS attacks, and etc., etc., etc. The tuples of the IPs to block the whitelisting, the blacklisting, the possible passes that to be limited to possible originating IPs. All of these security terms are to be positioned here in the Azure firewall. Remember, we can replace any Azure component with open source component, and the concept of the API gateway pattern still applies. So we have our passenger, he authenticates with Microsoft Intro ID or Keycloak, and then the mobile application receives the tokens, uses these tokens to communicate over an Azure firewall for filtering to the API gateway. The API gateway uses the tokens with a connection to Microsoft Intro ID so that it can get user information, verify the token, or any other functionalities, functional requirements that need to be allowed as well. And then over the communication can be divided in two branches. If the communication is to be routed to the booking service, then it's over in the Azure cloud. But then to overcross the borders between the Azure cloud and the on-premise, here we need a more sophisticated component, the BGP protocol. Border Gateway Protocol. It's actually designed for this to allow the discovery of the on-premise services by the cloud service. So this is a realization. Do you remember this arrow? It means realization of the Azure site-to-site VPN, and that means all communication between the cloud and the on-premise is tunneled over a VPN secure connection site to site. Remember, there is also point to site for devices connecting to the cloud or onto the WAN wide area network or on premise. There is also express service. There are many variants for the connectivity over public internet or over private link. This is a topic on its own to be discussed in a separate session, or if you are interested, you can review the relevant documentation on the possible options to secure the communication between the Azure cloud and the on-premise. Moreover, we see here the routing that goes over to the services or the modules on the premise. It could be also possibility that there is its own custom solution for gateway on the premise side, since this is a legacy application. For the sake of simplicity, we called all of the services on the premise as services, but remember these are modules member of a monolith application to stick to the constraints of this use case or case study scenario. One more component that is also quite important in this scenario is the Azure Connect Sync. This is also possible in other open source variants. This communicates the changes between the on-premise and the Azure Cloud in terms of new users, deleted users, updated users, roles and permissions that are being updated, RBAC or role-based access control, and so on and so forth. So with this pattern, we have covered one possible implementation or design of an architecture based on the API gateway pattern, should it in the context of a real use case or case study. And one to mention here is that the API gateway also is to be discussed as a component in the Azure Kubernetes service or Kubernetes in general, and there is also variants of gateways and ingress egress controllers that to be allowed for networking in the Kubernetes side. This also one of the topics that could be further discussed as implementations of the API gateway pattern. One more notice is that the API gateway pattern now, when it is offered from the platform, it's a platform service. So as an application designer or application architect, you don't need to do much digging and dragging into the topic and the implementation. So this is one of the things that you get off the shelf and start working with it immediately. I hope that you found this session useful and see you in future sessions.